Hello students. In this lecture, we are going to discuss how to determine the shear strength parameters of a soil by Triaxial test. Now, the shear strength parameters can be found out by several kind of tests like direct shear test, wind shear test, U-shear test and Triaxial test. But among these tests, the most important is the Triaxial test because all the other tests are having some limitations or drawbacks. Now we have already gone through the direct shear test, but this direct shear test is having some limitations. For example, the direct shear test is not applicable for cohesive soil. It is only applicable for the cohesion-based soil. This is the first limitations of the direct shear test. Number two, the failure plane is predetermined. That means the failure plane should be always horizontal for the direct shear test. It is assumed to be the horizontal plane. Okay. Now the third assumptions of the direct shear test that it in this test the drainage conditions cannot be controlled. So this is one of the another important drawbacks of the direct shear test. Now, if you are coming to the triaxial test, all of them are the advantages. So first of all, the triaxial test can be applied for any soil profile. Second one, there is no predefined failure plane for the triaxial test. And number three, the triaxial test, in the triaxial test, the drainage conditions can be controlled. That means by this triaxial test, we can conduct the drain test as well as the undrained test. That means here the drainage conditions can be controlled. Now, as we have already discussed, that these shear strength parameters are not the inherent properties of the soils. That means, suppose we are going to take one soil sample, a particular soil sample, and we are going to conduct a test for that particular soil sample in undrained condition and another one for that particular soil sample in drained conditions. Now, in these two conditions, the shear strength parameters should be different. That means the value of C and phi should be different. That means it also the C and phi value also depends on the drainage conditions. So here the drainage is quite important. So first of all, the we must know what are the difference between the drainage condition, that is the drain test or the undrained test. So first of all, we can say that for the drained conditions, what is necessary term is the excess water pressure. We have already discussed about this excess water pressure. Now this excess water pressure is actually one kind of water pressure which is getting generated when a vertical load is suddenly getting applied. Again, going into elaborate form. Normally, the water pressure are of two types. We have already discussed it in the previous class. So in this PDF, we can see that there are mainly two type of water pressure. Number one is the hydrostatic water pressure, and number two is the excess water pressure. The total water pressure should be equal to the hydrostatic water pressure plus excess water pressure. Now this hydrostatic, what is hydrostatic water pressure? Basically, whatever we are going to study in our effective stress chapter, the water pressure is known as the hydrostatic water pressure, which is constant if the groundwater table remains same at a particular plane. That means, for taking an example, suppose this is one of the example where the groundwater table is at this point, and we are going to determine the water pressure at point A. So at point A, the depth is 5 meter. So the water pressure should be 5 into gamma W, that is 50 kilometer per meter square. Now, this water pressure is known as the hydrostatic water pressure, which is constant if groundwater table remains same. I think it is clear. Now, excess water pressure is something else. This is not the hydrostatic water pressure. Excess water pressure is something else. Now, suppose if we are going to apply one vertical load on a soil sample, now what will happen? The load by some amount will be taken by the water molecules. Why? Because the water molecules are the most incompressible material of the soil sample. As we know that the soil sample is having air, water, and soil solid. So the water is the most incompressible material in the soil. So first of all, the water will take some amount of load, which is excess. That means this is known as the excess water pressure. Clear? Okay. Now, if the time proceeds, that means if the load is going to be sustained, then this excess water pressure is going to dissipate, is going to decrease with time to time. So we can say that the total water pressure is going to be again the variable, because hydrostatic water pressure is constant, but the excess water pressure is variable with time to time. That means the total water pressure is also going to vary. So if you are going to the slide, we can see that this excess water pressure is ignored in the case of the drain test, and the excess water pressure is there in the case of undrained test. Now what will happen in the drain test? In a drain test, we are going to allow the water to for being draining out. That means water is allowing to be drained. So if the water is allowed to be drained, what will happen to the load taken by the water molecules? The water will transfer the load to the soil solid particles, which is known as the effective stress. So we can say for the drain test, as the time proceeds and as we are allowing the drainage, so the excess water pressure is going to be ignored. Clear? Now, in the undrained test, that means we are not going to allow the drainage of the water. So the excess water pressure will stay there, because we are not the water is molecules are not going to be removed. So the excess water pressure will be always there in the undrained test. So this is one of the major difference between the drain test and the undrained test. So these two tests can be performed in the triaxial test. Clear? The second one, that is a drain test, is provides a long-term stability, and the undrained test is provides a short-term stability. What is long-term stability? What is short-term stability? We are going to discuss it in later few slides. Just now we are moving on. The third difference is the loading. That means the whether the test should be drained or undrained, it also depends on the loading conditions. If the loading is not sudden, that means we are going to make a stage loading. So in that case, we are giving some time. We are giving some time for the water to dissipate. That means for this particular conditions, also the excess water pressure cannot be stayed there. So when the load is not sudden, then it can be one kind of drain test. If you are going to give the sudden loading, then obviously the water doesn't have any chance to get removed, so the excess water pressure will stay there. So it is one kind of undrained test. So the sudden lead load is certainly going to generate the undrained conditions. The next one is very important. That is for the drain test. We had the total water pressure is equals to the hydrostatic water pressure. Why? Because excess water pressure is ignored or zero. So you can say the water pressure is equals to the hydrostatic water pressure. Now normally the excess water pressure is very difficult to determine in the field. So we can say the excess water pressure cannot be determined accurately in the field conditions. So if it is zero in the drain test, so we can easily determine the water pressure by simply calculating the hydrostatic water pressure. So in that case, we can easily calculate the effective stress also, simply total stress minus the water pressure. So we can determine the effective stress also quite easily for the drain test. But for the undrained test, we cannot determine the effective stress. Why? Because it is very difficult to find out the water pressure at the field. So the excess water pressure cannot be found out quite easily in the case of the undrained test. The total water pressure should be equals to the hydrostatic water pressure plus the excess water pressure. Excess water pressure is there in the undrained test. So in this case, we cannot calculate the total water pressure in exact or in accurate. So we cannot calculate the effective stress in accurate also. So in this case, whenever we're going to draw the Mohr circles, we're always going to draw the Mohr circle on the basis of the total stress consideration. That means sigma will be always the total stress for the undrained test. This is very important. For the drain test, we're going to consider the effective stress parameters. For the undrained test, we are going to take the total stress parameters. Now, in the drain test, the volume of the sample does not remain same. Why? Because for the drain test, the water is going to be removed. So, as the water is going to be removed, the volume of the sample is going to vary. For the undrained test, no change in volume because the water is staying there, so no change in volume. Only the variation is in the excess water pressure. That means, suppose whenever the test is going to be started, the port excess water pressure is something. At the end of the test, the excess water pressure will getting decreased by some amount. So the excess water pressure is going to dissipate or excess water pressure is going to vary. The volume remains same, but the excess water pressure is going to vary in the case of undrained test. But for the drained test, there is no concept of excess water pressure as it is zero. And the last one is last difference is for the drain test, mainly the questionless soil profiles. For the questionless soils are going to have the drainage conditions, and for the cohesive soils, they are normally termed as the undrained conditions. But this is not always true. In fact, also this cohesive soil sometimes it can act as a drained conditions also. We are going to discuss in later few slides, but this is not always true. That means this is not only depends on the soil conditions. So whether this is questionless soil or whether this is cohesive soil, it does not depend on the drainage conditions of the paste. But still, normally we can assume that for questionless soil, this is the drain test is applicable. For the cohesive soil, the undrained test is applicable. We are going to go into details of it in next few slides. Now, the next one is the triaxial shear test. The triaxial shear tests are mainly of three types. One is the unconsolidated undrained, in short UU test, the consolidated undrained CU test, and consolidated drained CD test. Now, in this particular three type of test, one thing is quite clear. That means there are two stages. Number one is the consolidated or unconsolidated, and number two is either undrained or drained. That means there are two number of stages. One is the consolidation stage and another one is the drainage stage. Clear? So the stage one, this is consolidation stage. Now consolidation will occur once the water is having the chance to get removed. That means if the drainage valve is open, if the drainage valve is open, so the consolidation is going to be permitted. If the drainage valve is closed, then we can say that consolidation is not going to be permitted. The drainage valve is actually being placed in a cell where the soil sample is to be taken. We are going to details of it in the next slide. But still, if the drainage valve is open, the consolidation is permitted because the water is free to flow. If the drainage valve is closed, then the consolidation is not permitted. Clear? The stage two is a drainage. Is a drainage stage. It is even termed as the shear stage. It is even termed as the shear stage. Now, in this stage two, we are going to apply the slope. We are going to apply the deviator stress. Now, in the stage two also, if the drainage valve is open, then obviously the drainage is permitted. If the drainage valve is closed, that means the drainage is not permitted. So this is one of the basics of the triaxial shear test. That is, the test are of mainly two stages, stage one and stage two. Stage one is a consolidation stage, stage two is a shear stage, or we can say the drainage stage. Here, in the stage one, the consolidation is permitted if the drainage valve is open. Even in the stage 2, the drainage is allowed if the drainage valve is open. Clear? Now, if we can see this figure, for the stage 1, if this is the soil sample, just wait a minute. If this is a soil sample, we are going to provide some cell pressure or some confining pressure at each of the surfaces. Here, it is to be embedded in this cell. It is going to be embedded in this cell. That means this is a cell within which this particular sample is going to be placed within a rubber membrane. Clear? And we are going to give some confining pressure throughout. We are going to give the confining pressure throughout the soil sample. So this confining pressure is known as the sigma 3, which is also the minor principal stress. It is also termed as the cell pressure. It is also termed as a confining pressure. So all of them are similar. All of them are same. Clear? Now in this case, in this cell, we can see the drainage valves. Clear? We have already discussed what are the purposes of the drainage valves. So here are the drainage valves. Clear? Okay, sorry. Okay, now in stage two, the confining pressure is there. The confining pressure is there. Also, we are going to apply a deviator stress, that is del sigma. We are going to apply a vertical deviator stress until failure. So, at a failure, the sigma 1 is going to be sigma 3 plus del sigma. So, at the horizontal plane, at this horizontal plane, the stress will be sigma 1 at the failure. At a vertical plane, the stress will be sigma 3, that is the confining pressure. This is stage 2, that means we are going to give the shear loading. So as we have discussed that the first type of test of the triaxial is the UU test. UU means unconsolidated undrained. Now we have already defined that what are the unconsolidation, what are the undrained conditions. That means there are basically two stages as I have told it before. For the first stage, the drainage is not permitted, the drainage is not allowed. That means this is unconsolidated test. On the second stage, the drainage is not allowed again, so it is making an undrained test. So for the UU test, for both the stages, the drainage is not allowed. I think it is quite easy to remember that when it should be the drainage, when the drainage should be allowed and when the drainage should not be allowed in the case of EU, CU and CD. I think it is well understood. Now, coming to this EU test, some features of the EU test. Basically, in this EU test, stage is not necessary at all. Whenever we are going to allow the drainage, then the first stage requires 24 hours of time. It requires 24 hours of time in the case of the consolidation of this particular triaxial test. But if the drainage is not allowed, then we don't require this 24 hours of time for the first stage. So this particular test is quite rapid. It only takes around 15 minutes. Here there is no first stage. There's only second stage where again the drainage is not allowed. If the drainage is not allowed, we have told it that for the undrained conditions, the rapid loading is there. It also depends on the loading conditions. So the loading conditions should be rapid. That is, loading rate is high. So in this case, in this EU test, the loading rate which should be applicable is high. Why high? Because the loading rate, if it is high, then there will be no chance of generating the excess water pressure. Sorry, the no chance of removing the excess water pressure. That means the excess water pressure will not have any time to dissipate. So the loading rate should be quite high as possible. So this particular test, EU test, is quite fast. There and in this EU test again, as the water is not going to be removed, the volume does not change. We have already discussed in the first slide. Also, we have to measure the excess water pressure during the test. Whenever the volume is not going to be changed, then the excess water pressure is going to change with that time to time. We have told it before. Clear? Now, in the lab, we must have one apparatus which can measure the water pressure, which can measure the excess water pressure. I have told you that it is very difficult to measure the excess water pressure in the site, but in the lab, you can measure the excess water pressure by some apparatus. So in the EU test, the volume does not change, so you don't have to measure the volume change. But we have to measure the change in the excess water pressure during the test. Though it doesn't have any functions, but still we can measure the excess water pressure during the test from time to time. Clear? And as this is an undrained test, it is the consideration of the stresses should be total stress. That means for drawing the mode cycles, obviously you have to consider the total stress into account. We have already discussed it in our first slide. Here. Now, the result of EVU test is something like this. Which is shown below. The sigma versus tau, that is a normal stress versus shear stress. Here the phi should be equals to 0. Here the phi should be equals to 0. She would be having some value. Here we have considered 3 more cycles. That means the 3 soil samples are being taken with different selfish. So whenever we are going to draw a common tangent, it should be completely horizontal, making the phi is equals to 0 for the EVU test. Is that clear? That means if the phi is equals to 0, so we will be having some value of C. Now this particular result is only applicable for a particular type of soil sample, which is normally consolidated soil. For over consolidated soil, the phi value can be 5 to 6 degree. So whether This particular soil sample is clay, it is cohesive, it is cohesionless. It does not depend on the CN5 value does not depend on that particular soil sample. It depends on the soil, sorry, on the taste conditions as well as the drainage conditions. So, in this EU test, always for NC type of soil, the phi value should be equal to 0. For over-concentrated soil, the phi value can be maximum up to 5 to 6 degree. Okay. Okay. Now, what is normally concentrated soil and what is over-concentrated soil? There is no time to discuss it in this lecture, but we are going to discuss it in the next few lectures, in the next video. Okay, now coming to our next test, which is the CU test. CU means consolidated undrained. So the first stage, consolidated, that means the drainage is allowed. The second stage, the undrained test, that means the drainage is not allowed. That means for the first stage, that is the consolidation stage, the drainage is allowed. The drainage is allowed. For the second stage, that means the CS stage, the drainage is not allowed. That means it is going to provide the undrained conditions. As we have told it before, that this first stage, that is the consolidation stage, requires 24 hours of time. This is one of the major feature of this U test. So the first stage requires 24 hours. For the second stage, for the CS stage, the loading rate is high. Why high? Because this is an undrained test. That means the loading rate should be high. That means the water does not giving permission to dissipate. That means the excess pore pressure will stay there as it is an undrained test. There. Now, again, the next feature, that is a volume change. For the undrained test, the volume does not change in loading stage. We have again told it in the first slide. The volume does not change. So we have to measure the excess water pressure, because the excess water pressure is going to change from time to time in the second stage. And again, it is undented, so it will be a total stress consideration. That means a more circle should be made of the total stress. So here we have drawn two number of more circles, which are more circles for total stresses. Clear? Now in this case, we have actually drawn a failure plane, which is having a phi value and which is having a C value. And we have told it that the C and phi value are not the inherent properties of the soil. It depends on the taste to taste and the taste conditions and the site conditions. So for this kind of taste, the phi value we are getting is actually denoted as phi Cu, and the quotient value is defined as the CCU and the phi Cu for consolidated undrained test. Clear? So this should be the result of any CU test. The next one is a CD test. So CD test means consolidated drain. So for the first stage and for the second stage, the drainage are allowed for both the stages, that making it consolidated and drain both. Now, thus like the previous test, the consolidation also requires 24 hours. But in this case, in the second stage, in the CS stage, the drainage is not allowed. Sorry, the drainage is allowed, as well as the loading rate should be very slow. Mind it, if the loading rate is quite rapid, then it can generate some excess water pressure, as we have discussed. So the loading rate also should be very slow, as well as the drainage should always should be permitted for the second stage. That means for the shear stage. So this particular test requires a very long time, as the loading rate is very slow. Taste, the volume is changing in the loading stage. Why? Because the water is going to be removed. As the water is going to be removed, then the volume will be getting changed. So the volume changes happen in the loading stage. So in this particular test, how much is the volume change is going to be measured during the test. And in this case, keep one thing in mind, that there is no excess water pressure, as the loading rate is quite slow, as well as the drainage is permissible. Drainage is permitted. That's why there is no chance of forming the excess water pressure. We are going to give the enough time to dissipate the excess water pressure. That's why there will be no excess water pressure. That's why we don't require to find out to measure this is water pressure in the lab. So only what we have to measure the volume change of the soil sample. Now, as is a drain test, so the Moore circle should be drawn with the help of the effective stress. Clear? Unlike previous cases, in the drain test, again I am repeatedly telling you, for the drain test, the consideration should be effective stress. For the undrained test, the consideration should be the total stress. Now the result should be like this. Now in this case, we can say for the NC type of soil, the failure envelope is passing through the origin. Is passing through the origin. That means whatever may be the soil sample, in the CD conditions, in the concentrated drained conditions, the failure envelope will pass through the origin for a normally concentrated soil. If it is over concentrated soil, then we'll be having some value of C. In this case, in this particular test, we have defined C as C dash, C dash of CD. CD means concentrated drain. This is for over concentrated soil. This the test is consolidated drain, and C dash means this is effective quotient, effective Shearstone parameters. So you can say C dash CD and phi dash CD as the consideration should be of effective stress. So we are going to denote C and phi as C dash and phi dash. So C dash CD and phi dash CD. Clear? Again, I am repeatedly telling you that for NC type of soil, for normally concentrated soil, the C value should be equal to 0. That means the failure envelope should pass to the origin. For over concentrated soil, there will be some value of the quotient which should be equal to C dash CD. I think it is clear. Now, the UU test, CU test, and CD test. The basic features, the results are well known to us. Now, suppose in us we are going to collect one soil sample from a particular site. Now, we are going to test it in our laboratory. How can we decide that particular soil sample will be tested under CD conditions or under CU conditions or under EU conditions? That means this CU, CD and EU must be having some practical significance. So going into that, now this practical significance can be given an example by taking an example of the earthen dam. So suppose for the earthen dam means the dam is getting filled up by the soil sample, by the natural soil. So we are going to construct the dam by our natural soil. So if the construction is quite rapid, so in this case, in this particular figure, where this is a dam, and in this dam we are going to divide it into 4 layers. That means the construction should be done in 4 layers. Now if the construction is quite rapid, that means this particular soil samples, suppose we have constructed the layer 1. Now, with giving no time, we are going to construct the layer 2. That means at the layer 1, whatever the soil sample is, will be done, will be doing the EU test. Why? Because the soil sample at one layer, at the first layer, are unconsolidated. This is not consolidated. We have not given the time to consolidate. So the soil sample is unconsolidated, as well as the rapid construction is there. That means the sudden load, the rapid load is going to act. For the rapid loading conditions, always you are going to use the undrained conditions. So for the rapid construction of the earthen dam, always the soil sample which are taken should be the EU test. That means if we are going to check the stability under the rapid construction of our earthen dam, then we are going to test the EU test, the unconsolidated undrained test. The next example, that is a rapid drawdown or dewatering. Suppose, for example, we are having one layer, the first layer and the second layer. So, for the first layer, before dewatering, the first layer was the groundwater table, or we can say the water table, not groundwater table. The first layer was the water table. Clear? Now, after dewatering, sudden dewatering or rapid drawdown, this this layer, this one layer, this first layer is going to be decreased by the second layer. That means this amount is dewatered. This amount is a drawdown. This amount is a rapid drawdown. Now, due to this rapid drawdown, this particular soil area will be having the undrained conditions. Why? Because they are having the water pressure. They are having the water pressure. Why? Because they're having the water pressure. Why? Because there was a layer of one, there was a water level at one, so it will be having some water in it, and we are suddenly dewatering the water at level 2. But this water in the soil sample will stay there, will not remove quite easily. So they will be tested under CU test. Why? Because this is consolidated after the earthen dam is going to be finished. If we are providing some time to live, then it will be consolidated. Clear? And due to this drawdown effect, there will be some water in it which cannot be removed quite easily. So the excess water pressure is going to be generated. So this particular test condition should be always CU test, that is consolidated undrained test. And the last one is a long-term stability. Long-term stability means suppose an earthen dam has lived a long life, and now we are going to check the stability of the earthen dam. So the soil sample below the dam is consolidated. Also, as it is for a quite a long time, that means the excess water pressure which got generated during the construction is dissipated during the time. As we have permitted the time, that means the excess water pressure is nil at that point of view. That means this is a long-term stability check which should be done by the CD, the consolidated drain test. Long-term stability and short-term stability. Short-term stability means we are going to apply a load, and at that point of time we are going to check the stability. That is termed as short-term stability. Long-term stability means we are going to allow some uh, time to consolidate it as well as to draining out the water. That means this water pressure is going to dissipate if you are going to provide a time. So for long-term stability test, we are always going to use the CD. This is just one example. There are several examples of EU, CU, and CD test. I've just taken one earthen dam example, and I've explained this three test. Okay, so that's all for this lecture. If you are having any doubt and questions, please let me know. I will try to solve it. Thank you.